of your heartbeat.
In order to get the position equation, first we have to set the general position equation, which is this one. Then we have to set the particular data for our example, which is the one over here. And last but not least, only set the equation based on our data, which is basically fill up on the blanks. We have in here that the initial velocity is 100 meters, therefore we put in here 100 meters. We don't know the time, so then we have to put an x, and also we can see in here that we have a plus 300. Okay, this plus 300 refers to the extra height of the building. First, we have to start with the position equation. Then we have to see the general equation for the limits. So after having this general equation, we only have to substitute the values. Okay, we can see in here we fill up in here in the blanks following all of our instructions, such as in here we have to put minus f of x, which is minus the whole function, as we can see in here. After putting up all these steps, we have to begin to simplify and to follow all of the rules we have known on the math course, and also to follow the limits rules. So we have to simplify all of our products in here. We have to add and then multiply and finally get this answer. Okay, at the end we only have to subtract the common terms, and which at the end we got the velocity equation. The velocity equation turns out to be minus 9.8 time plus 100. In order to get the acceleration equation, first we have to see some of the derivatives formulas. Those formulas are shown over here. A constant will always be equal to 0, a variable will be always equal to 1, and in here we have a case where we have a variable, a coefficient, and an exponent. In that case we have to follow this rule. First we have to set the velocity equation. Then we have to apply the first rule for this term, which turns out to get this. After simplifying, we get x to the 0 power, and also we have a 0 in here because a constant will be always equal to 0. Then after simplifying, we got the acceleration equation, which is minus 9.8. Okay, the form of the obtained equation, which is the last equation we got, which is the acceleration equation that we have to remember, that is acceleration equals to minus 9.8. The obtained equation has this form. It is an horizontal line. Well, why? Because we can see here that first of all, minus 9.9 is a constant. We can see here that, well, over our x-axis we have time. So as time comes over, as time goes to the infinite, the acceleration will remain the same. The acceleration will remain a constant. Therefore, the form of the equation must be an horizontal line.
Substitute x with a 2 in the position equation.
First, we have to start with our position equation, in which in here we have to remember that the x represents the time. Then we have to solve and substitute the fraction that sits over here. At the end, it gives us this result. We can see in here that it turns out to be a quadratic equation, so we can use the general formula. In here we have the general formula, and then we only have to substitute the values in the general formula, which turns out to be b is equal to 100, a is equal to minus 4.9, and c is equal to 300. After beginning with the process of doing the general formula, at the end we get this fraction, okay? So the answer will turn out to be 23 seconds, 0.6.